Thinking of learning Python? Hold on, just hear me out. This video could save you a month of time and struggle. So most Python tutorials in internet are designed for programmers or computer science students or for people with a technical and IT background. So if you try to master everything, so it could take you 6 months or more, and most of it won't help you to solve even a single scientific problem. If you are a physicist, a mathematician, or a scientific thinker, you don't need to master the entire language. You don't need to learn everything in Python. What you need is a sharp, focused toolkit. Just the right set of Python libraries that you can model physical systems, solve equations, visualize data, and run simulations. So fast, accurately, and efficiently. You only need to focus on the tools that are directly useful for solving scientific problems. This series is designed exactly for that. We are building scientific computing toolbox specifically for physics, mathematics, and engineering students. That's why this series is going to be different. In this series, I will explain it from the perspective of a science student. Our vision is to guide you to learn Python from the lens of a physicist, not as a software developer or a programmer. So this means no unnecessary discussion, no complex coding terms, just exactly what you need to solve the real scientific problems. If you stick with this series, I promise, by the end, you will be confident using Python as a powerful tool for physics, math, data analysis, and engineering, or any kind of scientific coding. So let's get started. So what is scientific computing? Scientific computing is the use of advanced computing techniques, algorithms, and simulations to solve scientific and engineering problems. So it blends with mathematics, computer science, physics, biology, or chemistry to study complex systems that are difficult or impossible to analyze analytically. Analytical methods are exact but primitive process. A step-by-step solution using formulas like solving an equation with pen and paper. In real-world science, it's too complex to solve non-linear equations, simulate any experiment, measuring uncertainty. It's very difficult to solve when thousands to millions of variables are involved. Application of scientific computing in modern science in 2025 are huge. To solve differential equations for fluid dynamics, modeling chaos, simulate nonlinear system and optimization problems, and many more. Second, in physics simulations, particle physics like simulating collision between different particles, quantum mechanics and quantum computing models, astrophysics like black hole mergers, stars formation, electromagnetic field simulation, simulating quantum worlds, Monte Carlo simulation in statistics, even in data science and AI integration, its applications are huge. To understand scientific machine learning and neural networks, real-time data analysis from the satellites in biology and medicine, disease spread modeling like COVID-19 was a major example of that. CT, MRI image reconstruction, and much more. To model robotics and control systems, application of scientific computing in engineering is huge. Even nowadays, climate science and environmental studies uses this scientific computing to analyze climate, modeling weather, atmospheric chemistry, etc. So you first understand why is scientific computing is important in 2025 for science students. Okay, so first reason is explosive growth of data and AI. So modern science generates vast amount of data, satellite data, gene sequences, particle collision. So scientific computing helps analyze this big data efficiently using tools like Python, AI, machine learning. Okay, second is modeling the real world. Whether it's simulating the climate or predicting the earthquakes or understanding the black holes, most modern research relies on computational models, so on scientific computing, on machine learning. Third is it bridges theory and experiment. Not all problems can be solved on paper or in lab. Computing fills this gap, making it a third pillar of science. Okay, so alongside the theory and the experiments. Fourth is, see, it's very essential in 2025 to learn a skill like that, because scientific computing is now a core skill for careers in applied physics, data science, engineering, biotechnology, finance, and beyond. It connects multiple fields where mathematics, programming, physics, AI, making students more versatile, more advanced. So this is not just another Python course. We are designing this series specifically for the students of physics, mathematics and engineering. By the end of this journey, you will be able to simulate any scientific problem using Python. And the best part is, you don't need to master everything in Python. So in the next video, we will break down the roadmap for learning Python specifically for scientific computing. You will get clear idea what you have to learn.